Hello students. Today we are going to discuss about electric potential. Electric electric potential and potential energy. So the first point should come in your mind about potential is the hidden energy possessed by a body. This is in general we say potential means hidden energy possessed by a body. Possesses by a body. We say it has potential. Now, when we talk about electric potential, so electric potential is the energy of a charged body in the electric field. So what is electric potential? Electric potential is the energy of a charged body or a charged particle in the electric field. In the electric field. Now, how this energy possesses by the charged body in the field? So what we say, the work done required to move a charged body in the electric field. The work done required to move a charged body in the electric field is stored in the charged body in the form of electric potential energy. Electric potential energy. Now this is in fact the concept of electric potential energy. Electric potential energy is what? Let us consider a uniform electric field. We represent this field directed towards in the right direction. Let us suppose this is a uniform field. We choose uniform field because we will get a constant force acting on that particle. So we always consider a uniform electric field. So choose one point A and choose a charged body Q. Now there are two possibilities. You can displace this charged particle from point A to the left side of this field, which is against the field, and you can move this charged particle to the right, I mean in the direction of the electric field. So you can do the both, but the point is it depends on the nature of the charged body. It depends on the nature of the discharged body. So let us consider this charged body is positive. This charged body is what? Positive. Now the natural tendency of this charged body is moving towards right or moving towards left. What do you think? Think about it. If this charged particle is placed in the uniform field and its own charge is positive, so the natural tendency is that it will displace by itself from point A to point C by itself. There is no need of external force, external agent to move from A to C, because this is the nature of this charge, that it will always flow in the direction of the field. So this is the work performed by the field. So as a result, the potential energy of this charged particle when it displaces from point A to point C, its potential energy decreases. Why? Because some of the energy of the field has been transferred during this work. So the work we represent by A. Let us suppose we represent AC, from A to C. Clear? Now we choose another point. Let us suppose this is point B, and the same charge of the same magnitude is placed now at point B. But now this time we wish to move it against the field. I mean, it should move towards the left direction, not to the right. So if this charged particles wants to move to the left, it will not go by itself. There is a repulsion because you are going against the field. So you have to perform some work, positive work you have to perform to move this charge body from point B to, let us say, point D. So this work, we represent this work as BD. Work is BD. Now one work has been performed by the field when the charge is moving, displacing it from point A to C, and another charge which is placed at point B, it is moving against the field at point D. The difference is what? This charge is moving by itself without any help in the direction of field. But this charge, when it displaces from B to D, you need an external help, you need an external work, you need an external force to move it against the field. So that work done, in fact, you perform from B to D against the field, against the uniform electric field, is stored in form of potential energy, and we represent it as delta U. So this is known as the electric potential energy of the charged body in the uniform field. Now, what is the electric potential? If you divide this work B to D by the same magnitude of the charge on both sides, delta U divided by delta Q, then this represents electric potential. Then this represents what? Electric potential. The difference is simple. The difference is simple. Electric potential energy, in fact, depends upon the work. You are moving it from A to B. In case of potential, if you see, it depends, it also performs the same work. But what is the difference? If you increase the magnitude of the charge, if you increase the magnitude of this charge, so what do you think? The same work will be performed? No. You need more work. Why? The charge is more, so you need more work, more potential energy. So I should write more charge in magnitude means more work required, large work required. As a result, more potential energy. More potential energy stored. Okay. So potential energy depends on the 2 points. The distance between 2 points is important, between C and A. If you increase this C point to here, so definitely you need more work. If you increase the charge magnitude, so the potential energy will be more. So potential energy, electric potential energy in the field depends on the two things. It depends on the distance between the 2 points. Second, it depends on what? On the magnitude of the charge. Since I'm talking about the uniform field, so I'm talking about a straight line, so let us make it simple that it depends only on these 2 points. Now, if you see this potential depends on what? It depends on the difference between 2 points, this potential and this potential, point A potential, point B potential. Let me write this. Delta V can be written as delta VD minus VB. If the potential of point D is more, the potential of B is less, this delta V will be more. So this is the first point. The second point, it does not depend on the magnitude of the charge. Why? It is the work done per unit charge. It is the work done per unit charge. So potential and potential energy is simple. Potential energy is the work, and potential is that work per unit charge. That is called potential. Now, there is a difference between potential and potential difference. In the next lecture, we would discuss more about potential and potential difference. So we explored the simple concept of the electric potential and electric potential energy, that it is related the energy possesses by a charged particle in the uniform electric field only when you displace it from one point to another point. Now, which work is positive, which work is negative? So hopefully we would discuss in the next lecture. Thank you very much.